Hi girls, so today we're looking at energy systems. Today I'm going to go through all three energy systems at once just to give you a brief introduction to energy systems. The next three lectures I'll step through each energy system one by one. It is quite a difficult unit of work. It's probably the most difficult you'll do in year 11 and also year 12. So it is vital that you make notes, you read the textbook chapter. You will probably need to listen to the next four lectures more than once. And there are lots of videos throughout these lectures, these next four lectures, so you do need to listen to them too and make some quality notes. These videos that I've included are really valuable resources, and it's probably the videos that you're going to get the most notes out of. So our success criteria for today, like I said, brief introduction to the three energy systems used for muscular work and exercise. You will have achieved success in this lesson if you can identify the characteristics of the three energy systems, identify the importance of ATP, and identify the role of the energy systems in synthesizing ATP. Now, like I've said, I've got lots of videos in the next four lectures, and I've also got a lot of diagrams. So I will be fuzzing myself out of the videos so that you can listen to those videos and also take screenshots of the diagrams that I've included. Okay, so energy systems for muscular contraction, very important slide. There are three energy systems used for contraction of our muscles. They are the creatine phosphate system, the lactic acid system, and the aerobic system. So like I just said, the body has three choices of energy systems to provide energy for muscular work and exercise, including two anaerobic systems, which are these two, and one aerobic. Understanding how these energy systems contribute to energy production and their limitations is really important in improving physical activity and performance, and in our context it's quite vital to improve our touch football play and more specifically our position that we choose. Which of the energy systems is used depends on the intensity and the duration of the activity. That's really, really important to understand. Okay, so I'll say that again. The intensity and duration, so intensity is how hard the activity is, duration is the time of the activity, determines which energy system is utilized, so very important that you get that down. Muscular contraction, another important slide. So our muscles require energy to contract or perform muscular work, and this can include anything and things we don't even think about, such as picking up a pen or getting out of bed in the morning, or doing a push-up or performing a physical activity, a physical movement. This energy is produced by the breakdown of a very special molecule called adenosine triphosphate, and I'll refer to that as ATP throughout the next four lectures. There are three mechanisms or energy systems that the human body uses to provide energy for the production of ATP. Okay, so the production of ATP revolves around using one of the energy systems. Okay, so there are lots of nicknames for these energy systems. You'll see lots of different nicknames on the internet, but for our purposes, we're going to be calling them and referring to them as a creatine phosphate system, the lactic acid system, and they operate anaerobically, so without oxygen, and the aerobic energy system, which operates aerobically, which means with oxygen. The resynthesis of ATP can occur in three different ways. If the resynthesis occurs in the presence of oxygen, it's labeled aerobic, and if it occurs without, it's labeled anaerobic. Okay, so two energy systems to resynthesize ATP. They are the creatine phosphate, the lactic acid, and that's done anaerobically, and we've got one that occurs aerobically, and that's called the aerobic system. Out of the way. So what is ATP? This is just a brief video that describes what ATP is. It's quite a good one, so I would take some notes. It's probably a little bit more simplistic than the textbook. So I'll play that now.
Adenosine triphosphate, or ATP, is the main form of stored energy in cells. It is the currency of biological energy in every living thing. We're going to walk our way through what ATP is, where ATP is synthesized, how ATP is recycled in the body, where we get the starting materials, and what functions require the use of ATP. In order to understand how ATP is synthesized and used, we first need to know where it is located. Every living thing is made up of cells. Different cells have different jobs that they carry out. but virtually every living cell requires the energy of ATP to carry out their specific jobs. Each cell makes its own ATP, and the majority of ATP production is done in the intermembrane space of the powerhouse of the cell, the mitochondria. ATP is made up of three main parts: an adenine, a ribose, and a 3-phosphate tail. Plants can synthesize ATP from the products of photosynthesis through a process called the Calvin cycle, while animals and ourselves synthesize ATP through a series of complicated steps: glycolysis, the citric acid cycle, and the electron transport chain, where the majority of ATP is produced. When ATP is broken down, the 3rd phosphate is removed from the molecule's tail. When this happens, energy is released, and the cell can use this energy to carry out different functions. Now that the molecule only has 2 phosphate groups remaining, it's called an adenosine diphosphate, or ADP. Di meaning 2. This state is considered low energy. In order for the cell to create more energy, the ATP must be recycled. You can think of ATP like a rechargeable battery. ATP is like a full battery with lots of energy available, while ADP is similar to a dead battery needing to be recharged. But how do we do this? Your body needs to get the appropriate nutrition in order to make the most of its ATP production. You can do this by eating foods that are high in complex carbohydrates like breads, grains, and pasta, and from foods high in protein like meat, eggs, and nuts. Cells break these down into products like glucose that is then turned into ATP. If you're not giving your body the nutrition it needs, it'll break down things like muscle tissue in order to make more ATP. So why is ATP so important? ATP is used for obvious things like muscle contractions while working out. It's used by plants to grow. It's used to move macromolecules in and out of cells. It's used to build amino acids and proteins that carry out cell functions. It's used in the transmission of nerve impulses in our brains. ATP is the energy we all need to carry out the functions of our everyday lives.
Okay, so just to summarize that video, we've got our molecule here. So we've got the adenosine, we've got the 3 phosphates. Now 1 phosphate breaks off to produce muscular contraction. Okay, now to resynthesize that ATP, we need to get energy from our food and creatine phosphate. And like I said, we'll go through food later on, so how we resynthesize ATP. But in the video, she's talking about carbohydrates. Okay, so ADP plus a P equals ATP. Now it's really important that that diagram goes around the circle. So when 1 phosphate breaks off, that produces ATP for muscular contraction, but then we need to put back together that ATP, and that only happens through energy from food and creatine phosphate. Okay, so just to summarize that, ATP is an energy-rich molecule found in all cells. It is needed to perform just about every single function in our human body every day, including cell respiration, growth, and repair. ATP is synthesized in the mitochondria of our cells and is often referred to as the energy currency of life. Okay, we need it to do any sort of work. ATP is comprised of adenosine and 3-phosphate, which is over there, and contains a lot of potential energy due to its structure. When the energy is required for muscular work, such as going for a run, a chemical reaction takes place in which ATP is split at the 3rd phosphate, so over there, and energy is released. Okay, so that's the whole process. The important thing to know, however, is there's only a short supply of ATP in the mitochondria of a muscle cell, and therefore our bodies need to continually remake or resynthesize ATP to sustain the exercise or muscular work needed for our daily activities. Once the ATP molecule is split and energy is released, the ATP must be reformed or resynthesized using another source of energy for muscle contraction to continue. And like I said, we get that from predominantly food or creatine phosphate, and we'll go through that at a later stage. So just to sum up ATP, really, really important that you do know that during exercise, the energy system used to produce ATP will depend on how long the exercise continues, so the time, how vigorous the exercise is, so the intensity of the exercise, and how well developed the person's cardiorespiratory system is, so your aerobic fitness, which we're obviously testing through the beep test. So this is just a brief diagram of the contribution of the three energy systems. Really important that you do take a screenshot of this diagram. We will be referring to it throughout the next 4 lectures. So we've got the phosphates, the creatine phosphate in the red energy system. Okay, and you can see here that's the first and foremost energy system we use straight away, but you can see it really depletes quite quickly. And you can sort of see after the first 10 seconds it's depleting. Okay, so it doesn't last very long. Then we kick into the lactic acid system. Okay, you can see here it doesn't really last long either. It kind of dips at that 50-second mark, minute mark. And then we obviously utilize the oxygen system throughout. You can see that's kind of like the background system. It's always there, and it kind of takes over probably around when that creatine phosphate system starts to really deplete. It's just a brief summary of the three energy systems. You can take a screenshot of this one, but I do probably prefer the other one on the next slide. It's just a little bit more in depth. If you do want to get down some things from this one, it would probably be the positive and negatives columns, so you can take a screenshot of this just for your record. So this is the one I like a little bit better. So the creatine phosphate system, it's obviously anaerobic. The speed of ATP production is very rapid. We pretty much get it straight away, but it doesn't last very long. What's our fuel source? It's creatine phosphate. And like I said, it's very limited ATP production. It only lasts for about 10 seconds. Limitations, your muscle stores become depleted limited quite quickly. Duration and intensity, it's used in sprints, so a 100-meter race, or any high intensity activity where there's that sort of max effort, so 95 to 100% of your maximal effort, and short duration, so 10 seconds. The lactic acid system, it's anaerobic. Speed of ATP, again, it's rapid. Fuel from food, so glucose, so carbohydrates. Quantity of ATP, it's quite limited as well. And obviously, given the name, the byproduct of the lactic acid system is a lactic acid buildup, which obviously causes muscle fatigue. So you think of those events such as the 400-meter, that's a killer for lactic acid buildup, and that race predominantly uses the lactic acid system. Duration and intensity, it's used in high intensity activity, so the 85 to 95% of maximal effort. So think of a 400-meter race. Think of a six sets, in touch football, so rucking it up for 6 sets. That's probably utilizing the lactic acid system, where you're working at maybe that 85 or more percent intensity, and it lasts for around 1 to 2 minutes. The last system is the aerobic system. It's obviously aerobic, it uses oxygen, it's very slow ATP production. We get the fuel from glucose and fats. Protein is the last resort. There's unlimited supply of ATP. That's the best thing about this system. Limitations, byproducts are water, carbon dioxide, heat, etc. They're not as limitations are not as significant as the creatine phosphate and lactic acid system. And duration and intensity, it's used in endurance or long duration activities lasting over 5 minutes, where there's that intensity of maybe less than that 85% of a maximal effort. So when we're looking at touch football, think about maybe a wing player just sort of running or jogging up and down, and pretend they haven't got the ball. They're just cruising up and down that sideline. Girls, just to finish, I'm just going to show a quick video of the energy systems all working together. This is a really good video, so you might need to play this more than once, and make sure you also take a screenshot of that table.
In many sports and athletic events, quick bursts of intense physical activity are involved. For example, cricket. Even though a cricketer might be relatively inactive for a good deal of time, actions like batsmen running, fielders chasing balls, and fast bowlers coming into bowl require explosive activity. Football is another example. While a footballer might be on the move more than a cricketer during the course of a game, explosive efforts can be intermittent, particularly for a goalie. Many swimming and running events also require quick bursts of physical activity, particularly those undertaken over shorter distances. We said earlier that when fast, explosive physical activity is undertaken, the anaerobic energy systems, the ATP, PC, and lactic acid systems, are the main sources of energy, with the aerobic system becoming dominant after around 30 seconds. But the energy systems don't work in isolation. Just about any sporting event or activity involves interplay between the three energy systems, all working together to provide ATP for the muscles. Consider a 100-meter sprint event. The three energy systems all start up at the same time and all contribute in varying proportions to the provision of ATP. In the first 5 seconds, it's predominantly the ATP-PC system that provides the energy. But it doesn't last long, with the lactic acid energy system being the main source of ATP synthesis between around the 5-second mark and the end of the race. The aerobic system is also providing energy, but not to any great degree. However, in events which last around 30 seconds or longer, the aerobic energy system becomes the main source of energy.
So girls, just to finish, that video talks about the duration and intensity a little bit different to the textbook. Okay, so the textbook, for example, says that the lactic acid system is predominantly used between 1 to 2 minutes, but that video was saying 30 seconds. It was also saying that the creatine phosphate system only goes to around 5 seconds. It doesn't really matter what you utilize. Look, I like the textbook. I see these 3 last little columns here. I see that a lot. I'd probably go by this, so take a screenshot of this, and in particular maybe make some notes about the duration and intensity for each of the 3 systems. But the important thing that you take away from that video is that the energy systems do not work in isolation. They all start up at the same time. Thank you.